Hello, and in this video I'm going to spend a few minutes explaining why I created this course when there are already so many C++ courses on the market. The clue really is in the word modern. I should perhaps have called this course Learn Modern C++ the Modern Way, but that would be rather clumsy. But anyway, that indicates what the special features of this course are. So it's modern C++ and it's a modern way of teaching it. So what does that mean? Traditional C++ is based on a standard that came out in 1998. It's a rather complicated and low-level language. It's difficult to learn, difficult to use, and it's difficult to write safe code. So you often end up with programs that behave erratically or crash unpredictably. In English we have a saying, to shoot yourself in the foot. With traditional C++ you can often shoot yourself in both feet and shoot all your colleagues in the foot as well, which is not a good thing. Modern C++ is based on a standard that came out in 2011 and is still being developed. There's one due out in 2020. So this is very much a living and active and improving language, as opposed to traditional C++, which is stagnant. Modern C++ has lots of new features and lots of improvements on the traditional features. So it's almost a new language, which is why it's called modern C++ to distinguish it from non-modern C++. So it's easier to learn, easier to use, and it's easier to write safe code. You can still live dangerously if you want to, but it's no longer compulsory. I would say that C++ is about as friendly now, user-friendly, as any comparable programming language. Modern approach. A lot of C++ courses are written by people who used to be C programmers and then they taught themselves C++ in the 1990s, so they basically learned whatever feature they needed to solve the problem they had at the time. So they tend to assume that people should learn C++ the same way they learnt it. So their courses teach C and then they add C++ features as an afterthought. So students have to unlearn a lot of things they already thought they knew, and then these new stuff is all presented in a completely arbitrary order, which doesn't make any logical sense. More recently, people have realised this is not a good way to teach things. It is perfectly possible to teach C++ from the word go, so students will learn things they can use for the rest of their C++ programming careers. They won't have to unlearn anything. They won't get confused by different ways of doing the same thing. And also, this gives you the opportunity to present features in the best order for learning them. So you start off with the fundamentals of C++, then you go on and progress until you reach the advanced features of C++. It's common sense, really. Now, there are not many courses that do this that I know of, and most of those tend to use traditional C++. There are a lot of courses that teach modern C++, but they use the traditional C++ approach. So you start off learning C, then you learn traditional C++ on top of that, and then you learn modern C++ on top of traditional C++. So there's an awful lot of layers to get through, lots of duplication and unlearning. So my idea is, why not learn modern C++ from the beginning? As far as I know, this is unique. Maybe I'm wrong, but I'm not aware at the moment of any courses that do both. So that's the unique selling point of my course. That's the unique feature of my course. Thank you for listening. I hope you find this approach is useful and worthwhile. Hello and welcome to my course Learn C++ the Modern Way. So I thought before we start talking about the course I'd better quickly introduce myself. Here I am. My name's James Reynard. I live in England near the south coast. That's my photo. So moving quickly on. I've been programming in C++ since 1993. Before that I started programming with BASIC and Fortran and Pascal and C and even a little bit of assembler. My professional career was developing C++ software for a number of large companies in the UK and in continental Europe, both as an employee and as a freelance consultant. I've also worked as a lecturer in a technical college, training students between the ages of 16 and 19 roughly. I've taken a number of Udemy courses to update my knowledge and learn other skills. When I'm not working on C++ courses, I enjoy ballroom dancing, photography and walking in the country where I live. Okay, so that's enough about me. Let's talk about this course. Hello and welcome to my course Learn C++, the Modern Way, the Fundamentals. In this video I'm going to introduce the course. So this course takes a completely new approach. I've torn up all the existing ideas on how to produce a C++ course and start it again from scratch. I've spent 6 months working on this. The course teaches C++ from the beginning, no other languages, using the modern version of the language. And also it explains concepts in a logical order, which should make them easier to learn, I hope. The course relates C++ programming to the basic structure and functioning of the computer. C++ is quite a low-level language in some aspects, so if you have some appreciation of what's happening underneath the covers, it will make you a better C++ programmer. The course tries to explain everything in simple terms. C++ has some rather abstract concepts, so I've tried to come up with good everyday analogies for explaining them. There's also quite a bit of jargon, but I do try to explain it before introducing it. Use of graphics. Some of the concepts in computer programming can be hard to visualize. The Chinese have a saying that a picture is worth 1,000 words. I've certainly found that's true with some aspects of C++. Putting a graphic to show what's happening in memory, for example, means that you don't need to try and visualize what it looks like. So this frees up brain power for actually understanding the concept. And if you have a small brain like me, that's rather useful. There are lots of quizzes and exercises. You have plenty of opportunities to test your understanding and get experience as you go along. The course doesn't just cover language features. I'm not trying to stuff you full of knowledge to get through an exam. I am trying to teach you how to become a programmer. The course gets you writing your own programs as soon as possible. So let's have a look at the structure of the course. So these are the sections. The first section is the introduction, this one. We start off with the introduction, which is this section. So we have some introductory administration. Then we set up the compiler and write our first C++ program. We have a little digression into the background. So this is some useful information about computers, operating systems and programs. Then we get started with C++. We learn the basic language syntax. We then get an introduction to functions and logic. We learn how to use functions to organize our code. And we learn how to make code make decisions, so we can write programs that respond to events. We then go into more detail in functions and we learn about procedural programming. We learn how to create our own data types for managing data. We get introduced to object-oriented programming. In the final section of the course, we get to learn a bit about classes and why they are useful. The lectures consist of a video and a PDF file. The video will usually do some or all of the following. So I'll explain a concept. I may describe a language rule or show you some programming technique. There'll usually be some sample technique, and quite often there's a mixture of some or all of these. The PDF is a set of exercises, so you can download this and keep it for your own use. It might come in useful if you're revising for an exam or preparing for a job interview, for example. Usually there's one exercise slide for each slide that's in the video. So for example, if the video has a language concept, you might be asked to explain the concept or answer some multiple choice questions about that concept. If there's some sample code in the program, you'll probably be asked to work that into a complete program. So this will allow you to test your understanding of the lecture material. If you find there are any gaps or things you're not quite sure about, you can go back to the video and review them. And also it gives you plenty of opportunity to practice your programming and gain experience of C++. Okay, so that's the introduction to the course. Thank you for joining me, and I'll see you next time. Hello, and in this video I'm going to try and give you some advice on the best way to learn from this course. So the first thing, which is probably pretty obvious really, is to try and get yourself a decent study environment. So somewhere where you can sit down and concentrate on the course, or stand up if you prefer. The idea is that you're meant to get involved with the videos and code along with them. So when you see some sample code in a video, type it out yourself, get out your compiler, text editor, IDE. If you need to, you can pause the video, then copy out the sample code, write a simple program around it, get that working, try changing a few things around, see what effects it has. See if you can guess what effect your change is going to make. If it doesn't do what you expect, which is quite common in C++, try and see if you can work out why. There's usually a logical reason, although it's often pretty well hidden. And if you make a mistake somewhere, don't worry, we all do. Try to work out what went wrong and how to fix it. Make notes as you're watching. If you hear anything that sounds important or see something that looks important, make a note of it. You can use whatever you like, a word processor document, a scratchpad app, pencil and paper, whatever suits you. Then when you get to the end of the video, don't rush off and start watching the next one. Stop it a minute, think a minute and try and summarise what you've learnt. Then have a look at your notes and compare it and see if there's anything that you missed or that you need to go back and revise. So almost every lecture slide has a corresponding set of slides with exercises in them. So for every slide in the lecture, there's a slide in the exercise slides, except for a very few where I couldn't think of a suitable one. Most of these are either multiple choice quizzes or programming exercises. The multiple choice quizzes give you 4 statements, some of which are true and some of which are false, and you have to identify which ones are true and which ones are false. The programming exercises involve working up sample code from the slide into working programs, just in case you weren't doing it during the lecture, and they also give you suggestions for things you can do to change around or try out. There are also a few exercises which ask you to explain concepts, explain what is meant by so-and-so. So this is all good learning experience while you're learning, and also if you want to come back later and revise the course. Programming is a practical activity. The only way to learn how to program is by writing programs. The only way you can maintain your programming skills is by continuing to write programs. So if you want to be a good programmer, you have to write lots of programs, and if you want to carry on being a good programmer, you have to keep on writing lots of programs. So programming is like learning to ride a bicycle or swimming or dancing. You have to actually do it. You can't just learn about it from reading a book or listening to someone talk about it. You really do have to do it. In fact, one of the things I do is ballroom dancing, and there's a television program called Strictly Come Dancing, and at the end of that they say, until next time, keep dancing. So I'm going to say at the end of every video, keep coding. I apologise if that gets annoying. The point of it is to remind you that you need to keep writing programs and writing code. So what kind of programs do you write? Well, apart from the ones in the exercises, if you can try and think up your own ideas, or you have some things that you want to try out, then by all means do that. That's a very good thing to do to improve your programming skills. If it's something that you're interested in, you'll probably do a better job and learn more from it than if just doing something that I've told you to do. So these can be serious programs which do something useful, or they could solve some sort of problem, maybe a maths problem or some sort of text analysis or something like that. Or it could just be a silly program which tries out some ideas or tests your understanding. It really doesn't matter, but try and write code that's as good as you can make it. So don't put any untidy hacks. Make sure it compiles cleanly without any warnings, certainly no errors, and that it doesn't crash when you run it. Write out with different inputs just to see if you can make it crash, and if it can survive that, then you're probably doing pretty well. So, sharing with a friend. Programmers generally have a reputation of people who don't really have any friends, and they spend all day sitting in a dark room. That's a cliche, really. It's a stereotype. In fact, in the real world, programmers usually work in teams, and if you're a team player and you're a reasonably good programmer, you're much more likely to get a job than if you're a prima donna and you're a brilliant programmer. You know, it's all about communication and being able to work with people. So if you can develop that while you're learning C++, that's even better. So if you have some friends, or maybe even just one friend who's taking this course along with you, so you can learn together, you can discuss problems, you can solve the exercises together, you can compare your code. If you're feeling competitive, you can even have a challenge to see who can solve the problem first, or who can come up with the best answer. And another useful thing you can do is to explain things from the course. So if you've seen a video on something, try to explain it to your friend. And also, if you can find a fairly intelligent but non-technical person who's willing to listen to you, that's even better, because you have to try and explain everything in terms that they can understand. So you want someone who's fairly intelligent, who could understand the concept if they'd done the same previous videos as you have, but they haven't, so you have to try and simplify things. And there's a saying, if you can't explain something to someone else, then you don't really understand it. So this is a very good way to improve your understanding. Okay, and finally, a bit of light relief. C++ is serious, but don't take it too seriously. So this is a game you can play with your friends who are learning C++. One of you leaves the room, or they sits with their back to the computer or whatever, so they can't see what's going on. The other players, they take some C++ code and they make 5 changes to it. So this could be changes that stop the code from compiling, or they could be changes. What sort of mistakes? Well, you should have one mistake that's really obvious, like misspelling main, and one mistake that's really pretty devious, like putting capital O instead of the number 0. And then you should have the other 3 which are in between. And then the other player turns around, comes back into the room, takes their earplugs out or whatever, and then they have 1 minute to find all the errors. Okay, so I hope that's been useful. I'll see you in the next video, and in the meantime, keep coding. Hello, in this video I'm going to talk about C++ compilers. So these are pretty much necessary when you're learning C++. These take your source code and turn it into a working program, we hope. This is a bit of a problematic area if you're learning C++. There isn't any standard C++ development environment. With Java you can download the official compilers from Oracle, which used to be Sun, but there's nothing like that in C++. So there's plenty of competition anyway. There are at least 12 different C++ compilers. I looked them up before making this video. I could only think of about 3 or 4, but there are actually 12 at least, most of which I didn't recognise, or well, I did recognise vaguely, but not ones that I'd have thought of. And there's also lots and lots of IDEs, integrated development environments, and also you can use text editors which have C++ editing modes, so there's a huge range of combinations. So obviously I'm not going to be able to look at all of them in this video. I'll just give you a couple of suggestions for each operating environment. And the other thing is we don't really have time to go in and show you how to download all these and install them. There are lots of tutorials online, both written ones in blog posts and articles, and also videos on YouTube. So have a look around and you should be able to find something that shows you how to do what you want to do. So let's start off with Windows. Visual C++ is Microsoft's own offering. If you're using this, try to get 2015 or later, the version of Visual Studio. So Visual Studio is the environment and Visual C++ is the compiler. If you have 2015, that has full support for C++ 11 and 14, and quite a lot of C++ 17 as well. I think they've actually just about managed full C++ 17 compliance. So well done to them, because they were rather bad at this in the previous years, but they seem to have got their act together now. 2013, if you have to use that, that'll support C++ 11, but not C++ 14. I think there's just one small area of this fundamentals course that uses C++ 14, and it's not critical. So you can get by with this if you have to use it, but try and get the later version if you can. So you can download and install this from Microsoft. There is a free version which is limited. I think they've now limited it to the point you can only use it for 30 days and then you have to upgrade or something like that, or at least that was the impression I got the last time I used it. It may have changed since then, or I may have missed something, but anyway, that's the situation as I understand it. So the other way to, I mean, there are other commercial products for Windows as well. The main alternative is to get a open source free compiler which is designed for a Unix environment, and then get a supporting environment which you can use to run this compiler in that environment so it feels at home. So min.gw is the main one. There's also something called Cygnus, C-Y-G-N-U-S, not sickness, Cygnus, as like a baby swan. So min.gw will give you the GNU C++ compiler, which is a very good compiler. And this will run in a command line environment. So you get a little command shell and you can type commands into that. You can download this and install this free of charge. There's a website for min.gw which has all the instructions on it. If you follow those carefully, you shouldn't have too many problems, I hope. One point you do need to note is that you have to set some environment variables after you install it. I think it's the home and the path variables. You need to do that so the command line environment can find the compiler. If you don't do that, it won't work. But that shouldn't be a problem if you follow the instructions. And that's just the compiler on its own, so you need to have some means of creating source code files. So you need to install some sort of editor. I use Notepad++, which is a free open source program. Sorry, not open source, I don't think, but it is freely available. It's not the same as the Notepad program that comes with Windows and is not very nice to use. This is actually a lot better, and it does have lots of modes for editing, which includes C++ source code. But you can use any other editor that you like. You just have to save your files in the directory where min.gw where the compiler runs from within min.gw. And that's why you need to set the environment variables to tell the compiler where the files are. Mac OS X, Apple provides the Xcode IDE and compiler, so that's a pretty sophisticated IDE. It supports quite a lot of other languages as well, so if you decide to go off and do Swift or Objective-C or Android, you can use Xcode for that as well. You can download this free of charge from the App Store. There is something about payment, but you don't actually have to pay for it. And there is also an option to install command line tools. So if you're using other IDEs or you want to use your own editor, then you need to have the command line tools available so that your own environment can pick up the compiler. Visual Code Studio is just the IDE part of Microsoft Visual Studio without the C++ compiler. You can download that free of charge and use it on a wide range of operating systems. So you can use that and then pick up the compiler that comes with Xcode if you like. Or if you want to be a bit more independent, you can use the Homebrew package manager and install the GCC compiler or the GNU C compiler. Or you can in fact install the CLang compiler, which is another very good free open source compiler. So if you use Homebrew, you'll need to provide your own editor. I think Brackets is quite a popular one for editing source code on the Mac. Linux, BSD and other versions of Unix. Usually these come with a C compiler, which you need because you have to compile the software for the operating system. It may well be that this C compiler will also compile C++. So if that's the case and you're happy with that compiler, you can just use it. If not, if it's your own computer that you've got Linux or BSD on, or you happen to be someone who has the rights to install software, you can use the package manager to install either GNU/CC or CLang, or you can download the source code and compile from source. If you don't have admin privileges, if you're using a computer at work or at college, for example, you'll have to ask the system administrator if they would mind doing that for you. And they might say no, but try and be nice, so maybe they'll say yes. There are various IDEs which are available to run on under the X, which is the GUI system for Linux, BSD and Unix. So in the graphical environment, there are various IDEs you can run within that. Most programs in fact use Emacs or VI or Vi. Vi is a very old and rather clunky looking program now, but there is a new version called Vim which does all sorts of fancy things like having different colours of text for source code highlighting, and you can also look at more than one file at the same time. And the other main alternative is Emacs, which is a very large and complex and programmable editing unit, you'll either love it or hate it. In fact, whether to use Emacs or Vi is the subject of lots of religious wars. So if you have a lot of time to waste, you can go online and tell people why they're using the wrong editor. But personally, I think it's much more sensible to learn C++ and do something useful with your time on this planet. Okay, so once you've got your compiler installed, how do you use it? Well, if you're using a typical IDE, you'll create a project, then you create some files and add them to the project. You write the source code, save it. When you're creating the project, make sure it's a C++ project, of course, and it might be an idea to make sure that it's a console or a command line project and not some sort of GUI that adds all sorts of strange things to your code. Then click the project menu and then build, and then it'll chug away in front of you, and hopefully you'll get a runnable executable without any errors. If you're using a command line program, you create files in your editor or the environment that you're using, write the source code in your files, and then save it. And then you type the command to start the compiler. Usually that'll be either C++ or G++, usually C++ for Clang or G++ for GNU. And then after that you put the names of the source code files, and then you press the return key. Running the program, if you're in an IDE, you click on the project menu and then click Run. If you're at the command line, you type in the name of the program and then the return key. So how do you find out what the name of the program is? Well, if you don't tell the compiler, the program name will probably be a.out or possibly a.exe on min.gw. The reasons for that are rather historical. It's basically short for assembly.output. Anyway, if you want a more useful name, you can change this. If you give the -o option to the compiler when you compile it, so you put C++, then you put -o, then you put the name you want for your program, and then you put the source code files after that. So this will compile test1.ccc and generate a program binary called test1. Okay, and that's it for this video. Thank you for joining me. I'll see you next time. Hello, and in this video we're going to have a quick look at compiler errors, which are the bane of anyone who's learning C++, or one of the banes. So basically the situation is that the compiler will go through your source code and check it for any errors before it generates the program code. And if it does find any errors, it won't generate the program code. So your source code has to completely obey all the rules of the language. So if you imagine you're learning a foreign language and you make a grammatical mistake in the middle of the sentence, the person you're speaking to will stop you from talking, and they won't let you speak again until you've fixed that mistake. So it is a bit annoying, really. The common cause of compiler errors is a syntax error. If your code doesn't follow the syntax rules, which is basically the grammatical rules for the C++ language, the compiler will flag the error. Quite often a syntax error is the result of a typing mistake. So for example here we meant to put John in quotes, but we accidentally stuck an extra quotation mark on the end. So the compiler will pick that up and you will get an error. Unfortunately, compiler error messages are rather hard to read. They tend to be written in a rather cryptic language, which makes sense to people who write compilers, but not necessarily to people who write programs. There's also the problem that often an error can cause the compiler to get confused and start producing several other error messages which aren't necessarily related to the problem. The good news is that compilers are getting better, very slowly, but they are getting better at giving useful error messages, and certainly they are better now than they were in the 90s. So let's have a look at the kind of thing you can expect to see when you make a mistake. So here we typed John with an extra quotation mark, so you can see there's quite a lot of output here, and it all looks very confusing and difficult to read. The secret here is to ignore the stuff at the bottom and go right to the top and then work your way downwards. So the first, that's not actually an error, that's a warning, but it does actually tell us what the problem is. You can see here the language missing a terminating double quote character. That's not terribly clear. But you do actually get this little arrow pointing at the bit of the code that's causing the problem. You didn't get that in the 90s. So this is already quite a big help. We know that there's something wrong with that quotation mark, and we also know that there's this line of code, which is where the problem is. So you can see here that there are some other errors here. These are actually perfectly legitimate and correct bits of C++, but the compiler is confused, and because of the error it's lost track of what it's doing. It thinks these are wrong as well. So if you started trying to work out the error from looking at these lines, you would get confused because there isn't actually an error. So you could waste quite a bit of time. So the important thing to do is to start reading the error messages from the top. So here's some advice on reading error messages. So as we say, go to the top, look at the first error message. Even if that doesn't tell you anything at all, it will at least tell you which line of source code is the one that has the problem. So the next thing you do, if you can't see what the problem is, you go to that line in the source code and have a good look at it. Double check it, see if you can find any mistakes. If there aren't any mistakes, then it may be that this line of code depends on something else that you should have done earlier but either didn't do or didn't do properly. So what you do then is you start working backwards from the line in the source code file. So you go up the file, checking it carefully until you get to the top of the file, and make sure that you have all the things in there that you need. I mean, quite common, if you miss out a statement, then that'll cause a problem later on. So that's the best advice I can give you really at this stage. It's a bit of a chicken and egg problem really. To be good at working out compiler errors, you need to have a good understanding of the language. But when you're learning the language, you need to sort out compiler errors, and you don't have a good understanding of the language. And the only way you can acquire a good understanding of the language is to sort out the compiler errors and go forwards. So it's a bit of a chicken and egg situation, but it does actually get better with a bit of practice. And I know it is very annoying, but as you get more used to it, you'll find out that the compiler does actually do quite a useful job in keeping you out of trouble. Not always, but maybe 70 or 80% of the time. So it is worth gritting your teeth and putting up with the aggravation. Okay, so I hope this helps, and I'll see you in the next lecture. Hello there. In this video we're going to see how to install and configure the GNU C++ compiler on Windows using min.gw and msys. So the first thing we need to do is to download msys2. Make sure that this is msys2 and not just msys, which is a much older version of the same software. The URL is sourceforge.net projects msys2. If you can't locate this, you can always search for it on the internet. SourceForge is a site which distributes a lot of open source software. It should be very safe and very reliable. With msys2 we will get something that looks like a command prompt when we run it, but is actually quite a good approximation to a Unix or Linux terminal. Then we can use that for installing Unix software. The one that we're interested in is the GNU C++ compiler, G++. msys2 will also give us a package manager which we can use for installing software, so that'll save us having to download min.gw separately. Min.gw is just a version of G++ that's been built to run in this environment. So let's start by downloading this. So we get this little counter here. If you get asked about cookies, you can answer yes or no as you prefer. It doesn't make any difference to the installation. So we're being asked to save the file, which I shall do. You can save this wherever you like. If you're not sure, you can put it on the desktop or in downloads. Personally, I prefer to keep all my downloaded files in my own directory, but that's just my preference. So let's save that. So as you can see, this is going to take some time, so I might skip the video, save you having to sit there and watch the clock count down. Right, so our program is now ready to run, which we're going to do. You'll need to have admin privileges for this, like you always do when installing software on Windows. So we get the usual Windows warning, are you sure you want to run this software? Let's assume that the answer is yes, so I'll click on Run. Next. So we need to tell the installation program where we want to install this. I recommend taking the default, unless you have a good reason not to. So next. Start menu shortcuts, again accept that. And then it goes away and starts installing. So we now have MSys2 installed. So if we click finish, it'll run the terminal. It's all the way over here. So that doesn't look terribly exciting, and we can't really do very much with it at the moment. What we need to do is to install the compiler. There's two different commands that we need to use depending on the version of the compiler we want to install. If we want the 32-bit version, we should install this one. And for the 64-bit version, we need to install this one. Unfortunately, I haven't found a way to copy from this slide into the console window, so I'll have to type it out by hand. So I'm going to type in pacman. So this will cause the package manager to run. -S is the option to install things, I presume. We type in min gw -w64 -x86 _64, I think it is. Yep. Then -gcc. Okay, so it's found it anyway. Do I wish to proceed with the installation? I'll put Y for yes and press return. And it's going away and finding all these packages that we need to get a C++ compiler into this terminal. If you do get errors like this, don't worry, it means that it couldn't download that package from one server, so it goes to another server and tries its luck, so it has a pool of servers that it can try to download from. So unless you're very unlucky and it fails with all of them, then it shouldn't be a problem. I did actually get this before when I was trying this out, where not all the packages were downloaded, so I just ran it again, and the second time it did work. It only picked up the ones that it didn't already have. Alright, so now it's installing the packages. Alright, so now we have the compiler installed. Unfortunately, we can't run it just yet because the compiler has been installed in a directory on Windows, and this MSys terminal doesn't yet know which directory it's in. So we have to go and set that up, and we have to restart the MSys window so it can pick that up. So I'll just type exit in here to get out of it. I need to go into the control panel and change the environment settings on my account. So that's user accounts, and then change my environment variables. I don't know if this is still the same in Windows 10. I'm using Windows 7, and Microsoft does tend to change these things for no obvious reason. So I need to add a new environment variable. It's going to be called path. So this will tell programs starting up which directories they can look in to find other programs that they need. Windows already gives programs a list of directories when they start up to find Windows programs, but we can use this for adding directories for our own programs. So the next thing we need to do is to go to a file explorer. We need to find the directory where we installed MSys, so that's C MSys64. Then we go into the min GW64 if we installed 64 bits, and if we installed 32, I assume it would be that one. And then we go into the bin directory, and that's where the G++ compiler executable is. You can also type in C++ if you prefer. So we need to give this directory to MSys when it starts up, so we need to add it to the path environment variable. So I can click up here and that'll turn it into a normal Windows directory path. Then I can do Control-C to copy it. Then I paste that into the value of the path variable, and then I do OK. One other thing I do, which isn't necessary if you're going to be running min.gw from an IDE, if you're going to be running it from an integrated development environment, I like to be able to compile things directly in the command line. So to do that, I add another environment variable, which is called home. And when msys starts up, it'll actually go into this directory and work in there. So if I put the directory where I put my C++ files, this could be any directory that you like. So when I start up msys and run my compiler, the compiler will be compiling files that are in this directory. I can close this now. And if I start up msys again, so start and then type in min.gw, 64-bit. And now the moment of truth, if I type in G++ to run the compiler, if I put -v, this will print out the version of the compiler. And it's worked. So it has found the compiler binary. It prints out a lot of very verbose information about how it's been configured. But we do have the version right at the end in there. And I happen to have a file in here called hello.cc, which is a very simple C++ file. So if I type in G++ and then hello.cc, it's going to go away and convert that into a binary file. The output is called a.exe, but if I run that straight away, it won't work. And the reason for that is that by default, it doesn't look in the current directory when trying to find programs to run. So if I put dot, which means the current directory in Unix, and then /a.exe, that'll mean the file in the current directory, and then it finds it, and it says hello world. So we've now written a C++ program. I like to work with this in the command line. I use an editor called Notepad++. This is not the notepad that comes with Windows. This is a separate program that you can download very easily from the internet. So here's the hello world program. Don't worry about what this does, we'll go into that later. You'll notice that different parts of the program are in different colours. This is called syntax highlighting, and it does make it a lot easier to work with program code. To get this, you need to have something called text ft added, which is this. It used to be part of Notepad++, but now you have to install it separately. So if you want to do that, you go to Plugins, Plugins Admin, and then you can either search for it or scroll down this list. I've already got it installed, so it's not here, but if it's not installed, you can select it here and then install it. If you want to be able to use min.gw with an integrated development environment, such as Eclipse, which some courses use, which is not my favourite, or Visual Code Studio, which is just the editing part of Visual Studio from Microsoft without all the huge amount of baggage that it carries around, you can do that with this, but you do need to add something else. So I'll show you how to do that. So if we do pacman again to get the package manager, -S and then make, this will install some other files which are needed by the IDE to control the compilation process. So I'll type Y for yes, then return. Then this will be a nice quick installation. Yes, there it goes. So again, I need to change the environment so that this will get picked up. So I go back into Control Panel, User Accounts, Environment Variables, and I need to edit the path this time. Go into Edit. I need to find out where the make file has been installed. So I go back to msys64. This time I look in user, then bin, and if I, yes, there's the make file. So this is the directory that we need to put in the path. So I'll just do that, same as we did before. To have more than one directory in an environment variable, we need to put a semicolon between them. So we can just paste this in after the semicolon. Don't put any spaces in here because that can mess things up. Then we can close that and close that. And in theory, we should be able to run Eclipse with that. So I happen to have Eclipse installed, so I'm going to try and do that. Again, I have a pretty simple C++ program here. The details don't matter. If I do project build, it should, yes, amazing, it does work. So this is actually Eclipse, which has picked up the settings for min GW from the environment variables. So there we are. I think I need to go and lie down now. Okay, so that's it for this video. Good luck with your programming. I'll see you next time, but meanwhile, keep coding. Hello there. In this video, we're going to download Visual Studio with the C++ compiler. So this is the URL that you need to go to, visualstudio.microsoft.com/downloads. It should look like this, although it may look quite different if Microsoft changes it again, which they have done since the last time I recorded this video. If you're not a Windows user, you might be interested in Visual Studio Code. This works on Mac and Linux as well as Windows. This is just the editor part of Visual Studio, so you can get this to work with your compiler if you've got G++ or possibly CLang, or maybe even min GW on Windows from the last video. So you can just download this and use it with your compiler as a simple low overhead environment. Talking of overheads, Visual Studio is pretty big. It's a download of 1.6 gigabytes. It takes about half an hour on my broadband connection. So if your connection is not up to speed, this may not be the right solution for you, I'm afraid. The version we want to download is this one, Community, free for students, open source contributors and individuals. If you're doing commercial work or working for a business, then you need one of these, which are not free of charge and you have to pay for them. So let's start downloading this one. So first of all, we need to download and save this file. You can save that anywhere on your system if you like. If you can't think of a suitable place, you could use the desktop. So we'll save that. This page is very busy, so we'll go back to the previous one. Now we need to run this executable. So we get the usual Microsoft security warning. Do you trust Microsoft Corporation? Well, that's a big question, but we'll assume the answer